So here we are studying chapter number 14, chemical kinetics, and the next topic is this average versus instantaneous rate. What is the meaning of average rate and instantaneous rate? So average reaction rate, basically we are talking about the reaction. Average reaction rate is determined between 2 points of time on a curve. It does not tell you specifically what happened between these 2 points. And instantaneous rate is determined at a point in time. It tell you what is happening at that time, but not what is happening before and after. So for an example, if you are traveling from A point to B point by the car, suppose this is a 60 miles and you travel in 2 hours. So the average rate will be 60 divided by 2, 30 miles per hour, right? But what is the instantaneous rate? So instantaneous rate you can read from the speedometer of the car. So at particular time your speed could be 55 or 75 or 25 or 35. So speedometer will tell you is exactly instantaneous rate at particular time, and average rate means from A to initial to final distance per unit time. So let's see how we can calculate understand the average rate and instantaneous rate in the graphical format. So average rates, suppose this reaction is happening where butyl chloride react with the water to form butyl alcohol and hydrochloric acid, and this is the concentration is plotted on the y-axis of reactant and butyl chloride. This is the reactant, and time is from left to right is increasing. So this is the concentration is decreasing, it means reactant is consuming over the time. And if we have to find out the average rate of this reaction between these 2 points, this one and this one, so this point is falling around 150 seconds and this point is falling around 800 seconds. So what is the average rate between the 800 second and 150 seconds? So we can calculate by slope of the line that connect 2 points, provide average rate over an interval or time. So we can write m, basically slope will be equal to delta y over delta x. And instantaneous rate determined at a single point in the time, and that is calculated through tangent line. So average rate calculated by the making a slope between the 2 point, and instantaneous rate we can calculate by writing a tangent line. So we'll see one example after this. So average rate, once again, average over a period of time, and instantaneous rate is determined at a single point or tangent line. So in this graph it shows that initial rate here, if you will draw a tangent line means the line which is touching this point. So suppose if we have to write a tangent line at this 0 point, so we will write a line like this one, write a line which is just touching like this one, did not appear. So this will be tangent line which is just touching the 0, and at 0 time instantaneous rate will be 0 because reaction did not started. Slope of the tangent at a single point provide the instantaneous rate, and so either you can write make a tangent line at this point, or you can also make a tangent line at this point. which is falling around 600 seconds. So this point was selected, and you can write draw a line which is just touching this line, like this one. So this is called the tangent line. So tangent line means the line which is touching this line is called tangent line. So you can take any 2 point. You can take, suppose this point is taken and this point is taken. So the delta m you can calculate from by drawing a straight line on the left hand side from here to here to find out what is the change in molarity, and the time you can find from here to here by drawing a line on from top to bottom to find out what is the change in time here. So that will give you instantaneous rate. So let's talk about one question, then we can understand. The same reaction is there. Now they said calculate the average rate from 150 minute to 750 minute, and calculate the instantaneous rate at 150 second and 750 minute. Sorry, minute. Both are minute. Oh, actually the graph they are showing second, so I should cancel this minute. I should say seconds. So let's talk about in the second. So first we will calculate the average rate between the 150 to 750 minute. So what we can do, average rate we can calculate. Basically in this graph we are showing instantaneous rate. Let's talk about this. So in this graph I just want to show you that whenever you have to write a tangent line for any point for calculating instantaneous rate, you have to make a straight line which is just touching this point only, and that's it. That is called tangent line. So if we have to calculate the instantaneous average rate between 150 second, which is here, and 750 second, which is here. So draw a line from which is, and then find out where these time is connected with the your graph. So this graph, and then write a line, draw a line from this point to left side to find out what is the molarity at this point. So this point is falling between 0.07 to 0.08. It's somewhere very close to 0.07. So I just write 0.072 molar, and the molarity at 750 second is a straight line going in between the 0.02 and 0.03. So this will be half of this one, 0.025. So this will be my initial molarity m1, because initial time is 150 second, and this will be my m2, final molarity at 150 second. So we can calculate the rate of this reaction will be equal to, now you can see there is a 1 to 1 molar, so there is no need to write any coefficient in the denominator place. So rate will be disappearance of butyl chloride will be equal to negative change in molarity delta T. So initial molarity minus, this is final molarity minus initial molarity, final molarity m2, this is like m2 minus m1. So 0.025 minus 0.072 divided by 750 minus 150 second. Once you will calculate, you will get the rate of the average rate, which is 7. And okay, so you have to divide by subtracting the seconds also. 750 minus 150 will be 600. So this value after subtraction divided by 600, you will give you 7.83 times 10 minus 5 molarity per second. So this is the example for average rate calculation. Now we will see how to calculate the instantaneous rate. So instantaneous rate calculation I would like to show you here first, so that you can understand how we are going to calculate. Suppose we have to calculate the instantaneous rate at 600 seconds. So we will draw a tangent line and we can choose any 2 point in this line. So I'm choosing one point this and another point here, which is crossing the y-axis. So this will be my initial molarity and time will be 0, T1, and final molarity will be M2 at 600 second. So this will be like M2 minus M1 divided by T2 minus T1. So we can write the rate of disappearance. This is for instantaneous rate. M2 minus M1, T2 minus T1. So M2 is 0.03 minus 0.068 divided by 600, and then you can calculate the instantaneous rate. So same way, let's talk about the same question where it was saying that we have to calculate the instantaneous rate at 150 second and 750 seconds. So here in this slide I showed you how to calculate that instantaneous rate. So first I draw a straight line at 150 seconds. So first you have to find out where is the 150 second in the time x-axis. So which is this one here, 150 seconds. So draw a straight line to find out where is 150 second is crossing this curve. Then draw a tangent line which is just touching 150 seconds. So just touching 150 seconds, draw a straight line that will be tangent line. This will be tangent line for 150 seconds. So what I did here, I selected this point and draw a straight line back to the y-axis to find out what will be the molarity. This will be M2, and I choose another point which is touching the y-axis. This will be my M1, and then time T1 will be 0 and T2 will be 150. So we can calculate instantaneous rate at 150 second, M2 minus M1. M2 will be from here to here, which is 0.072 minus 0.09. M1 will be 0.09. It's in the graph you cannot see that. You have to either take a approximation or you can exactly, sometime you have to guess it, right? Or if it is exactly matching with the number, that number will be your molarity. So subtract these numbers, subtract 150 minus 0, this will be 150. So molarity and minus sign ones will be cancelled once you will open the parenthesis. So this is the rate at 1.2 time 10 to minus 4 second. This is the molarity per second. Molarity per second, this will be rate at 150 second. Same way, once we have to calculate the average instantaneous rate at 750 second, you have to draw a straight line like this one, just touching the point at 750 seconds. So I already draw a straight line with a pencil, and then what I have to do, I have to find out any 2 points. So this point at 750 second, this will be my, I consider it as M2. Draw a straight line from here all the way to back, which is crossing to the y-axis, which will be M2. This will be my M2, and initial point I again selected at y-axis. You can choose any 2 points from here to here, from here. Don't go outside of the curve, otherwise you will not get the values. So you can choose any 2 values. I choose here y-axis, so it will be easy for me to for subtraction also, and then to find out the molarity also. So this time for 175 seconds, molarity is between these two, 0.02, 0.03, and molarity at m1 will be 0.06. So we can write instantaneous rate at 170 and 100 at 750 second will be rate m2 minus m1 delta t. m2 is 0.025, and then put the negative sign on outside also. 0.025 minus 0.06 molarity divided by 750 minus 0. So subtract that molarity divided by 750 seconds, you will get the answer for instantaneous rate. Rate will be 4.7 times 10 to the minus 5 molar per second. So now you can also see that the instantaneous rate at 150 second and instantaneous rate at 750 second, basically this graph shows that rate of reaction is decreasing. So it was initially 1.2 times 10 to the minus 4, and now it is 4.7 times 10 to the minus 5, so minus 5. So rate is decreases. So these are the two examples where I have shown you how to calculate the instantaneous rate and average rate. And if you have any question, please feel free to write, and then I will try to answer you as soon as possible. Thank you.